All right, part 2 of lesson 8. So it starts example 4 here, and it says solve the following polynomial inequality. X cubed minus 4x is less than or equal to 4x squared minus 16 in the way indicated. And it tells us to factor it. So remember, in order to factor, the first thing is it has to be set equal to 0. So we're going to subtract the 4x squared, and we're going to add the 16. I'm just going to write that up here. So that'll be 0 on that side. So we have x cubed minus 4x squared minus 4x plus 16 greater than or equal to 0. Now we're going to treat this just like it's equal to 0 so we can find what we call those critical values. Those critical values are those points that create those intervals in my table. So remember, those are your x-intercepts and your vertical asymptotes. Well, this is just a polynomial. It's not a rational function, so it has no vertical asymptotes. So we're going to find those x-intercepts. So we're just going to treat this like it says equals 0 in order to find those critical values. And it does tell me to factor it. So remember, this has 4 terms, so to factor it, this is where we split it in half. And so we greatest common factor this side. So I take out an x squared. That leaves me with x minus 4. I'm going to take out from this side, this piece, a negative 4, which leaves me with x minus 4. And then we greatest common factor the whole thing. So I have the x minus 4 times what's on the outside, which is that x squared minus 4 equals 0. And so I could keep factoring, though, because that second parenthesis there is a difference of squares. So I have x minus 4 times, remember, take the square root of both of them, so x plus 2 and x minus 2. Difference of squares has 2 of them. So in order to find the critical values, then we're just going to set each of them equal to 0. So x minus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. And so we get a critical value at x equals 4, x equals negative 2, and x equals positive 2. These critical values are the x-intercepts for this one because it didn't have any vertical asymptotes, and these are going to be where we would break our intervals up at. All right, so to keep going on this one, it wants us to show it analytically. So it wants us to work this out and show whether it's positive and negative and where it's happening at and how we get our solution. All right, so we're going to make our sign chart, and I'm just going to use that as one of the lines, I guess, in my chart there. So I'm going to have my interval, my x value, my y value, and the sign. And I'm going to put plus or minus there instead of writing it out. All right, so we know our interval is going to start at negative infinity. And it goes to the smallest critical value there, which is negative 2. Negative 2 to the next smallest, I'll move that down a hair, to the next smallest critical value, which is 2. 2 to the next smallest, which is 4, which is also the biggest. So then the biggest one all the way to positive infinity. Now remember, your infinities always have parentheses, but now that we have an inequality sign, we got to think, can it equal that critical value? Well, look at your inequality sign. If it is an x-intercept, which is where all 3 of these came from, it can be a parenthesis or a bracket depending on the inequality. If it's a vertical asymptote, like we'll talk about later, then we know that the vertical asymptote, it can never equal because, well, our graph never crosses. So when we look at this inequality in the original problem, it's where we got it equal to 0 is the main one because we don't always look at that other one, but we always look at this one then. All right, so when we look at that inequality, we see it has the equal to. And so the equal to tells us that the x-intercepts will have brackets. So because the negative 2 was an x-intercept, put a bracket. The positive 2 was an x-intercept, so put a bracket. The positive 4 was an x-intercept, so put a bracket. If it didn't have the equal to, then we would use parentheses on all of them. All right, so we're going to pick an x value in each interval. We're going to plug them in and solve for y. It doesn't matter if you use our factored form or if you use the original problem. So let's do that. Let's plug in each one and solve for y. Now also let me specify, when we're plugging it in, we're plugging it into either this one when I say the original, okay? It always is when it's equal to 0. So either we plug it into that form or we can plug it into our factored form or any of the forms in between those two actually. All right, so let's take and let's plug in our first x value, which is -3. And so when I got that, I got -35. So it's negative. Then let's plug in 0. I got 16, which is positive. When I plug in 3, I get -5, so it's negative. And when I plug in 5, I get 21, which is positive. All right, now how do I know which one is my answer? So let's go back to our inequality and let's look at it once we had it with a 0. We are looking for where it's less than or equal to 0. What kind of numbers are less than 0? Negative numbers. So this is where I'm looking for where it's negative. So I'm going to go to my table, and we said it's negative right here. So when I go to my solutions, it's negative between negative infinity and -2 with a bracket. And we can also see it's negative right here. So union 2 with a bracket all the way to 4 with a bracket. And so there is my solution. Now, so graphically, we can graph this. We know we have x-intercepts at 4, -2, and at +2. Looking up there where I have it less than or equal to 0, I can see its degree is 3. So I know my end behavior is going to go in opposite directions. And my leading coefficient is positive, which means the right side's going to go up. So because they go in opposite directions, the left side goes down. Each of my x-intercepts had a multiplicity of 1, which means it's just going to cross. So we know our graph is going to look something like this. All right. If we're looking for where it's going to be less than 0, would that be above or below the x-axis? That would be below the x-axis. So we can see our graph is below the x-axis right here, which is all the way from negative infinity up to that x-intercept right there of 4, and it's equal to. And then we can see it's also below the x-axis right here, which is between 2 and 4, and it's equal to, so we use the bracket. And so we get the same exact equation, or excuse me, same exact solution that we get whether we look at it graphically or analytically, which is the same problem, so we should get the same exact answer.